Hey everyone, it's Bob Crossan, Senior Managing Editor of Water and Waste Digest. I am here today with Miguel Arguelles. He is Project Director for McCarthy Building Companies. Randy Rogers, he's the Houston Waterworks Team Chief Engineer, as well as Pau Vranesic, Director of Houston Waterworks Team. We're going to be talking about the Northeast Water Purification Plant Expansion Project in Northeast Houston, Texas, serving primarily the northern service areas and the far western service areas of the city of Houston. So thank you all for being on the call. I really appreciate you taking the time, and congratulations on a top project for 2021.
Thank you for speaking with us about it.
Yeah, of course. This is an enormous project. I wanted to start with that first. Could you talk a little bit about the size and scale of this? I don't know which of you would like to take on that question first, but I'll pose it to Paul, and if you're not the best person for that, you can bounce it over to someone else.
Sure. The intake pump station for which we have won this award is actually a fairly sizable component of a massive overall project. The Northeast Water Purification Plant Expansion Project is approximately $1.8 billion in new capital investment infrastructure for the city of Houston and its regional water authority partners. And the intake pump station is about 75-80 million dollars out of 1.8 billion.
Hmm.
We've had as many as 1,500 people working out here every day, hundreds working on the intake pump station, thousands who have touched it over its time. And we're roughly at about 5.6 million man hours overall with zero lost time accidents. A lot of that has to do with the tremendous professionalism that our partners such as McCarthy bring to the project and the great work that they're delivering.
Hmm. So, personal curiosity of mine, which I've been asking all the top projects, is the project delivery method for each of these projects. What is the delivery method that was used for this project, and what was the reasoning behind choosing that one?
Okay, so the overall Northeast Water Purification Plant Expansion Project is a progressive design build.
Okay.
Houston Waterworks team is the proponent, and within the overall, so we are the contractor. Within that overall project are a series of sub projects, of one of which is the intake pump station. We put together a request for proposal that we made a competitive selection um, based on a technical qualifications and price submission made by various firms. McCarthy put forward an excellent proposal, and they were selected on the basis of being the best value for Houston Waterworks team and the city of Houston and its partners.
Hmm. So, I wanted to pass this to Miguel as well from McCarthy's side. I understand this is considered the biggest progressive design build in the country, is it not? I believe that that was my understanding for this project. Could you talk about the size and scale of this from the McCarthy element as well?
Yeah, so from the McCarthy side of things, I guess we signed up as a subcontractor to HWT. I think it's 60% design drawings. And then, just specifically talking about the intake pump station, we were looking at a job, a 20,000 square foot pump station housing six 1,000 horsepower vertical turbine pumps that would eventually push 320 million gallons of water per day on these large twin 108-inch diameter, pipes down to the main plant, and all this, this building, this pump station. I mean, if you think what I just said about, if you think about what I just said, it looks, sounds like a pretty complex big pump station. But when you throw in that it's on a concrete structural concrete slab, 1,000 foot over Lake Houston, with limited lay down space, limited access, it got us very excited about this challenging opportunity it's really not just a water project for us. It brings in the marine components as well. It's got a dredging scope, driven piling, these, massive structural concrete slab is supported on 30-inch piling. For us, it was a big self-performed project. And again, we kind of went through our national business, and we brought in resources from all over the country with water expertise, with marine expertise, and then commercial building expertise to be able to execute on this, execute this project.
Yeah. Now, Paul, you had mentioned that this is part of a much bigger project, and last year, I believe, one of our top projects was also part of this. This was the Luce Bayou Interbasin Project. How does this specific project, the Northeast Water Purification Plant, or is it NEWPP? Is that how you guys are pronouncing it? How are how does this project specifically integrate with that one? Like, what are their relationships to each other?
Well, Randy could expand on this a little bit, but if we were just to withdraw water from our intake pump station from Lake Houston, we would drain Lake Houston. So the Luce Bayou Interbasin Transfer Project takes water from the Trinity River watershed and pumps it into Lake Houston. And then we basically take that water into our pump station. So there are two connected projects. The Luce Basin Interbasin Transfer Project is not part of NEWPP, but it is certainly very important to NEWPP. And Randy can expand on some details.
Paul, the Interbasin Transfer Project allows us to draw from the Trinity River watershed, which starts way up north of Fort Worth. So we're taking North Texas water, combining that with South Texas water through the San Jacinto watershed and the branches, the tributaries to Lake Houston directly. The combined water supplies allow us a firm yield out of the lake of 560 MGD, which is the ultimate build out of the existing plant and our plant to serve as the flagship for the City of Houston surface water supply treatment plants.
Yeah. One of the challenges that was mentioned in the nomination form for this project was the raw water source and how that presented some problems for this particular part of the project. Could you talk about that aspect, and then also how that was further complicated by storm events and whatnot? My understanding that really presented some unforeseen consequences as well. Could you talk a little bit about that?
Sure, Bob. We're at the end of the freshwater supply here in southeast Texas. So after the water flows over the dam at Lake Houston, it becomes brackish and flows out to the Gulf. So we are at the end of the watersheds, both for the Trinity River and the San Jacinto River watershed. So when it rains, we see what we call a phenomenon called flashy water. And that means that the stability of the alkalinity of the water drops, the alkalinity falls dramatically. The turbidity increases because we are in a shallow lake. The intake pump station that Miguel talked about is only in 23 feet of water. And when we had the Harvey event, we were flushing this lake about 18 times, 18 complete flushes of the lake in a 24-hour period. So we had to gear up for a rather robust treatment process. Making good flock was one of our themes at the beginning of the job. If we do that right, everything else kind of takes care of itself. So we have two recipes for coagulation here, a wet weather recipe, primarily using alum, and a dry weather recipe using ACH. And that gives us a lot of tools to make good flock, and then the downstream processes take care of themselves once we remove the heavy solids and the organics in the flocculation sedimentation basins.
Oh, that's a tremendous amount of flushing for the Harvey. It doesn't surprise me given the scale of that event, but that's just so much work to have to do on top of the work that was already there. Moving on to some of the construction elements, could you talk about some of the logistical hurdles of constructing the pump station on the lake? What was involved there? Miguel, you had mentioned some like pilings and stuff like that. Could you talk a little bit about that construction element?
Sure, Bob. So like I said, logistics was a challenge on this project. The location of the site and access to the site. You know, to bring in all of our construction materials, we had to come in through the main plant that's being currently built through that, you know, $1.8 billion plant, and then had to cross all the construction going on, and then cross this mile-long, very narrow, you know, stretch to get to the actual site. So, and then everything, you know, that was part of this project, all the construction materials were, I mean, there were huge, you know, 108-inch diameter pipe, 120-foot long pile, tons of, you know, rebar and steel. So just getting to the project, to the site, was a challenge. So it took a ton of coordination with our HWT partners, you know, daily communication about what was going on in the plant that day, that week, so we could plan for all these, you know, trucks going in and out to our site. And then, you know, halfway through the project, you kind of throw in COVID, and we couldn't meet in person. So that added layers, you know, added of just communication challenges throughout the life of the project. So coordinating just-in-time deliveries because of our limited laydown space at, you know, on land at the site. Also, you know, just getting materials from land to water where everything was being built. We had to build a temporary loading and unloading facility just to get, you know, concrete, rebar, pile, pipe down to the work area. And again, everything that we built was in a massive scale. So, you know, traditionally you build, you know, your pump station, your building, and then you import, you bring in all of your process piping, your equipment. In this case, because the piping was, you know, so massive, we had to install a bunch of the process mechanical components prior to, you know, erecting the building. So, you know, building a building around large pipe, protecting the pipe, keeping everyone safe on a limited, you know, concrete area in the middle of the lake, that was very challenging. But again, through, you know, communication, coordination, planning, with our HWT partners, with our subcontractors, with the PMT, we were able to successfully, you know, complete the work.
Mm-hmm. So you mentioned these pipes, like these very big pipes. I understand that the pipeline pressure, expansion, and contraction were also concerns. How did you address that matter of the project? Was that just an understanding of like the design work ahead of time that kind of bled through, or was that something you had to do within the construction period as well?
We followed Mr. Randy Rogers' directions.
Yeah, Randy, could you speak to that?
Yeah, I can start with the design premise. So pressure, fortunately, is fairly low. There is a little bit of surge pressure, but the real dynamics come out with when we analyze the pipe when it's empty and it's exposed to the hot sun in the summer, or empty and exposed to weather like we had minus or 18 degrees Fahrenheit we had during the February storms of this year. So, and it's a long straight run, so there is expansion contraction that has to be accounted for. We used a number of flexible couplings through the whole length of that run, so that the pipe could expand into itself when it heated up, and contract out of itself when it became cold. And that all has to be held in a straight line. At the same time, it's, you know, like an accordion going in and out, especially when the pipe is empty. So that was accounted for very early in the design, and we have numerous flexible couplings along that 1,000-foot run out on the bridge there. Once we're underground, it's a piece of cake because the temperature stabilizes, but out on the deck on the lake, it can be a very flexible situation.
Yeah. Well, and having a good flexible coupling like that can be, it just works wonders. Solves so many problems that you would otherwise run into as well.
Dozens of them.
Yeah, I imagine it's just like coupling after coupling. It's got to look. I think we have some photos. It looks really, really tremendous. But last question before we get to some shout outs was safety. Something that Miguel had touched on as well. Could you talk about some of the safety elements that were involved with this project? How did you make sure that to keep workers safe? You're talking about these enormous pieces of equipment, these enormous pipe pieces. The pilings are hundreds of feet long or 100 feet long. Um, could you explain a little bit about some of the safety concerns that were involved here and how you made sure that people were being safe on the project site?
Yeah, I mean, that was our top priority from day one. Is how are we going to keep our folks safe through the construction of this pump station? And we focused on planning the work and execution of the work. So, and when I talk about planning, it's generating detailed, comprehensive work plans for every installation. And then once we think we're there, do internal peer reviews to get feedback. And then once we think we've got 100% bulletproof plan, share it externally with our HWT partners and get their feedback, and then share it with PMT and get their feedback. And the more people the more eyes that we get on these plans, the better they're gonna be. And then once we've received all that feedback, is communicating the plan to our craft employees or craft partners. And one of our biggest challenges that we face is a communication barrier that we have a lot of times with the craft workforce. So we focused on generating visual plans. So I look at at the time 2 and 4 year old kids assembling these kind of Lego models, and they couldn't read or write at the time. And then, it kind of dawned on me, Lego has this great model of they communicate a set of instructions to people that can't read yet, right? Mm-hmm. We focused on the visuals on our plans for communication and color coding systems and step-by-step pictures and where to place your hands and where are the danger spots, and using just visual communication in that way to communicate with non-English speaking or non-reading, partners. And then to date, I mean, we're 99.9% complete. We've worked a little over 250,000 man hours just on the pump station alone, with 0 recordable incidents, 0 lost time incidents. So we're almost to the finish line, and just knock on wood, here in the next couple of weeks. But we've been successful in the most important front, which is the safety front for us.
Yeah. So real quick, we only have a couple more minutes, but I do want to get some shout outs. You mentioned this huge number of man hours, 250,000 man hours just alone on this pump station. Wanted to get a little bit of shout outs from each of you. So Miguel, could you, is there anyone you want to shout out for this project?
I mean, if I start naming, individual people, I don't think I can the next hour. So all the McCarthy, staff and craft workers, HWT, PMT, our partners, some of our subcontractors, Walker Engineering, they, took care of all the electrical packages at the pump station, Mid-America Pipe, Victaulic, ITT Goulds. They were all great partners and had a significant impact on this, building the project successfully.
Yeah. How about you, Randy? Anyone you want to shout out?
Well, there at its peak when we were in detailed design, and we're producing 5,400 drawings that it took to depict the required construction out here, we had somewhere around 200 to 250 design professionals and modelers, BIM modelers in motion. Most of those came from either our affiliate partner, Jacobs, or CDM Smith. And then a lot of additional work came from our MBE partners that we used on the job. So they did a yeoman's job putting all this together in the amount of time that we had to put the project get it into the constructor's hands so they could start doing their takeoffs and start building some of the early work packages. So I shout out to all of those 250 some professionals that made that possible.
Yeah. And Paul, you got very limited window to get in your your shout outs.
On this overall project, the $1.8 billion NEWPP project, we've had more than 10,000 people whose efforts have touched the project in one way or another, many of whom touched the intake pump station, and they have all done brilliantly well, operating as a seamless team, producing fantastic work in a very safe and high quality manner. And we just couldn't be happier for the efforts that they produce every day as a whole.
Yeah. Thank you all for being on the call. We really appreciate your time.